Hey there. We are in Unit 2, Lesson 5. So we're still talking about linear equations, inequalities, and systems, but today, today we are going to continue talking about linear equations. It's not a but today, it's today. Nothing different today. We're still talking about equations and their graphs. So we're going to graph equations in two variables. In Lesson 4, we talked about writing equations in two variables. And actually at the end of the lesson, if you remember, we were talking about snacks and how many calories were in a snack and how many calories went to the protein and how many calories went to the fat. So I think it was 4p plus 9f equals, I think we started with a 60-calorie one. And as we went on, the curriculum started to replace it with x and y, which was foreshadowing the fact that we are going to graph the x-axis and the y-axis, where the x-axis is the protein axis because it's x, and the y-axis is the fat axis because it's white. That sounds terrible, doesn't it? Let me dismiss this. Okay, let's do a which one doesn't belong. So I see three graphs, and which one doesn't belong? What can we talk about it? Let's see, they are all, well, this one's dollars, hours, dollars, hours, dollars, hours. Here's hours and dollars, so maybe that one doesn't belong because the x and the y-axis have been shifted. So that's a possibility. If I go here, like maybe this one, because this is a negative slope. You guys remember slope? Change in y over change in x. As we look from left to right, the line goes down. I always think I read books from left to right because that's when we read sentences from left to right. I always think of a skier going down a mountain from left to right, so that's the negative because it's going down. Here's a hiker going up. That's positive because you're gaining elevation, whatever. That's what I always think about. Maybe it's this one that doesn't belong because it's not a line, it's dots. This is called a discrete graph because it is dots. This means that at this value of hours, you make this amount of money. At this particular value of hours, you make this amount of money. There's no in between. All right, where this one, as another example, I can do infinitely many hours, dollars an hour combinations, but this one is only the particular dot, nothing in between. This one starts from 0, 0, which is cool. That's what that one is. These look like the exact same graphs, but this one is a line and this one is discrete or dots. Okay, to get snacks for a class trip, Claire went to the bulk section of the grocery store where she could buy any quantity of a product and the prices are usually good. Claire purchased some salted almonds at $6 a pound and some dry figs at $9 a pound. She spent $75 before tax. All right, bowl of fig and almonds. Okay, whatever. If she bought 2 pounds of almonds, how many pounds of figs did she buy? What's our equation? Okay, we need an equation. So here, let's say these are almonds and these are figs, and that's how much she spent total. So $6 a pound for almonds plus $9 a pound for figs is the total amount, which here is $75. So she spent $75. If she bought 2 pounds of almonds, we don't know how many pounds of figs she bought, but we know she spent $75. We can figure it out. Okay, we can reason, we can use our algebra skills. I'm going to do 6 times 2 plus 9f equals 75. If I subtract 12 from both sides, I'm left with 53. $63, silly me. So that gives me, I'm going to continue up here, 9F equals 63. Divide both sides by 9, and I have F equals 7. So she bought 7 pounds of dried figs. It's funny, the figs are the more expensive part. I think I'd buy more almonds. I really like almonds, so I'd buy more almonds. Okay, does that make sense? So first I had to set up an equation, and then I can use the equation for number 1, and I can use the same equation for number 2. Okay, this represents her mix. She spent $75. We don't know how many pounds of almonds, how many pounds of figs, but we know she spent $75. So here she bought 1 pound of figs. How many pounds of almonds did she buy? So I'm just substituting here. 6A equals 66. I'm going to move it up here. So I'm solving for A. A equals 11 pounds of almonds. Cool? Okay, continuing on. This beginning is all the same. So write an equation that describes the relationship between pounds of figs and pounds of almonds that Claire bought and the dollar amount she paid. Be sure to specify what the variables represent. Yeah, my mind works in equations, so I did that in advance. But let's do the whole question so we answer all the parts of it. So I wrote the equation, and I have to say that A equals pounds of almonds. And F equals pounds of figs. And then the total amount that she spent equals $75. Cool? So write an equation that describes your relationship and the dollar amount she paid. Be sure to specify what the variables represent. Check. Ooh, here is a graph that represents the quantities in this situation. Choose any point on the line, state its coordinates. Sorry, I need to see what the data is because I've already turned to my page, but you have it all in front of you. State its coordinates and explain what it tells you. So let's look at this point. This is 2, 7. That's an ordered pair. It represents 2 pounds of almonds and 7 pounds of figs. So 2, equals 2 pounds of almonds and 7 pounds of figs. Choose any point on the line, state its coordinates, and explain what it tells us. And that would be for a total cost of $75, right? I could choose this point. Well, let's do this point. So that would be 11, 1, and that would be 11 pounds of almonds and 1 pound of figs at a total cost of $75. Cool. This would be, it looks to be 6.5, 4. Okay. Here, 1, 1. What does that represent? 1 pound of almonds and 7 pounds of figs. And she spent less than because it's not on the line. So she didn't spend $75 when she did that one because it's not on the line. Okay, these three ordered pairs they are all on the line. So the amount of almonds and the amount of figs that were purchased are all $75. Okay, this one right here is not on the line. Okay, spent less than $75. If I had an ordered pair out here, that's also not on the line, but that would be more than $75. Okay. Oh, B, choose any point that's not on the line, state its coordinates, and explain what it tells us. Check. And then we made our own point, which yellow is very difficult to see, isn't it? We made our own point up here. That would be more than. Cool? Okay. All right, what does the point, now we're just reviewing, what does the point 10.3 mean in this situation? That would be 10 pounds of almonds, 3 pounds of figs, and I'm not sure if that's on the line. I'm going to check. 10, comma 3, and spent too much money. Is that a possible combination of pounds of figs and almonds? Why or why not? It is not. I keep getting ahead of myself. It is not, because that ordered pair is not on the line. We could say it that way. Or because 10, what is it, $6 per pound, $9 per pound. I think that's what the equation is. Let's look. 6 and 9, yes. So if I do 60 plus 27, that's 87. That's more than 75. Which if you go back to the graph, you'll see that's this point right here. And it's above the line, so it's too much money. From the graph, it looks like 7, 3.5 might be a solution, but it's hard to know for sure. Is there a way to verify? That's, 7, 3.5. So over 7, it looks like it might be 7, 3.5. How could we verify that? We plug it in. 6 times 7 plus 9 times 3.5 equals 42. 6 times 7 is 42 plus 9 times 3.5. That equals 73.5. Okay, so that's not equal to 75. So that ordered pair would not be on the line. It would be slightly below the line. Okay, it would be slightly below the line, because they did not spend the full $75, they spent less than 75. Suppose we extend the two ends of the graph beyond the first quadrant. Oh, this is so important. Would a point on those parts of the line, say -1, 9, be a solution? Let's look. If we extend, let's just stick with red. If we extend this and we now have our x-axis, that's a terrible line. We now have our x-axis further this way, and we went -1, sorry, that shouldn't be a dot, -1, comma 9, -1, comma 9. Is that a valid point? Let's check. It is 81 minus 6. So I have -6 plus 81 equals 75. Okay, it's on the line. Is it a valid point? Is it a solution? Does it make sense? It doesn't. Can I buy -1 pounds of almonds? No. Okay, so that does not make sense. This -1 doesn't make sense. So when we have real life situations in algebra class, we need to say our domain has to be positive numbers. I can't spell positive. Positive numbers, because I can only buy positive numbers of pounds of almonds and figs. I can't buy a negative amount. Even though the math works out, like that works out. So misleading, but no, not possible. Okay, it's just not possible. All right, let's try our last activity. That took a little long, but it's really good information. So a student has a savings account with $475 in it. She deposits $125 of her paycheck into the account every week. Her goal is to save $7,000 for college. How much will be in the account after 3 weeks? Let's see. She already has $475. And she deposits $125 each week. Her goal is to save $7,000 for college. How much will be in the account after 3 weeks? So I will have $475 plus 125, 125, 125. $850. How long will it take before she has $1,350? So that's 3 weeks. Let's see, week 4 would be plus 125. That's $975. Week 5 would be plus 125. That is $1,100. Week 6, let's just do this a little bit better. That'd be week 3. Week 4 was $975. Week 5 was $1,100. Yeah. Week 6, $1,225. Week 7, $1,350. So week 7, she has saved up $1,350. Okay? Write an equation that represents a relationship between the dollar amount in her account and the number of weeks of savings. I got a little ahead of myself up top, but I didn't use the equation to solve it. So that would be the dollar amount in her account. So total amount in her account, $475 plus $125 per week. All right, now graph your equation using graphing technology. Mark the point on the graph that represents the amount after 3 weeks and the week she has $1,350. Write down the coordinates. Okay, I'm going to push pause and open up my calculator. All right, I set up my Loom incorrectly today, so I can't use my TI emulator. So we're going to use Desmos, and then when we're in class together, I will go over the calculator for you. So the equation we wrote was T equals 475 plus 125 a week, right? So I can't use T and W in my equation, so I need Y equals 475, and I would actually recommend you doing this along with me. You can split your screen and practice, but there's my equation. Okay, 475 plus 125, not W, X. Okay, I need to reset. My head keeps moving. I need to change my x and my y-axis. So this is a real situation. That means that our x-axis is just going to be positive numbers. So 0 to, I don't know, we were at 7 weeks. Let's do 10 weeks. I don't know why I'm typing in there. Sorry, this would be 0 to 10. That's just 10 weeks, and our label would be weeks. The y-axis, I'm going to start at 0. I know I'm at $125 or $475 to the beginning, but I'm wondering like how much, like we want $7,000. So let's just give us a little bit of space. Let's do $7,200. And our step would be, no, our label would be amount. Okay. Looks like, is that what we wanted? Yep, let's not go that far. I just want you to see a little bit more. We were at 1,350, so let's go here. There we are. So here's our graph. I'm going to drag it just a little bit so I can see my XY axis a little bit better. If we see, so it wanted us to, how long will it take before she has 1,350? That was 7 weeks. Write an equation, check. Graph your equation using graphing technology. Mark the points on the graph that represent the amount after 3 weeks and the week she has 1,350. So 3 weeks would be 3 comma, what did we have, $850. That's what we calculated. So it's right there. Okay, it's on our line. That makes sense. And then the next part was, and the week she has 1,350. That was week 7. 7 comma 1,350, and that's also on our line. What's cool is I can say y equals, actually, I'm going to delete that. I'm going to hide it. I'm going to show you something else. If I say y equals 1,350, that's going to give me a line. And I can click on that line and show the solution. So that's another way to find the solution to an equation. I can draw in y equals something and find out what x equals at that point. If I turn that back on, you would see it. When I turn that off, there's my dot. That's how Desmos works. Okay. Cool. Write down the coordinates. Now, how long will it take for her to reach her goal? Now I need to change her y-axis. Her goal was 7,000, so I just need a little bit of room. So I'm going to do 7,100. I'm going to turn off these points and move my head. I want to know what, how long it takes her to reach her goal. Her goal was $7,000. There we go. I need to see more x values. Nope. So I'm looking for where that red line up high crosses my curve or my blue line. So 40 weeks, 60 weeks. I think that's it. Right there. Okay, $7,000. It took her 52.2 weeks to reach $7,000. That's a long time. Okay, let's see. And really, I can't do 52.2. Let's go back here. Desmos. I use Desmos to graph, and graphing this on your graphing calculator is a little bit more difficult sometimes. We wrote down our coordinates. How long will it take her to reach her goal? 52.2 weeks. I can't do 0.2 weeks. We have to say a whole week, so 52 isn't enough money. 53 would be a little bit more. So we're going to have to go with 53 weeks using Desmos. Okay, that was fun. That was tough. Lots of information in there, right? I leave myself some more paper. Oh, let's do another one, all right? So here I have a tank of water. and I'm going to have to finish this after lunch. All right, so I'm going to push pause.